All right, hello, welcome. This is the technical breakout session, specifically focused on getting you into some of the beginnings of the technology and talking a little bit about what you'll need to know from the C++ and maybe the operations side in order to kind of compete in the hackathon. My name is Bart Wyatt.
And I'm Khaled Al-Hassanieh.
And we'll kind of be your guide through this process. We're going to kind of walk you through a couple things. Here's an agenda of what we're going to talk about. Please hold questions until specific gaps. We're gonna break it up into kind of a beginning that I'll run you through, and if you have any questions, that would be an appropriate time to ask. Then we'll switch over to Khaled, and he'll kind of hit some of the deeper details of contract development and some of the topics that you might need access to during the hack. In between those two sections, though, we will open it up for a first round of questions just to make sure we haven't lost anyone. And then at the end, we'll open it up to even more questions where you're free to ask anything about anything we've covered or anything we haven't covered in particular. So as I said, I'm not going to read that for you. This is kind of where we're going. I'm going to go ahead and dive into it, and we'll get to Q&A at the end. So I'm going to informally kind of walk us through this whole thing after I close a bunch of windows that I left open. All right. So as we discussed in the opening ceremony, we've got a Docker set up for you that will help you get into this process. We're not going to go through installing Docker right here in this presentation. If you need to have some help installing Docker when you get back to your station, there are plenty of mentors around that can help you do that. If you haven't pulled down the Docker image, it might take a little while. Once again, just to reiterate, we are using version 1.2.5 during this hackathon. The latest is 1.3. It should be, for the most part, compatible, but it's just going to be out of the scope of this hackathon. You'll be better served by using 1.2.5. You can use basically whatever coding environment you want. We're not tied to a specific one. So if you like to use Sublime, Vim, CLion, all of them should be able to get you through the process. We have some specialized tooling that we're going to introduce you to. When we're going through this process now, I'm going to show you how to basically get it set up conveniently so that you can use what comes down in the Docker image to develop contracts, and I'll kind of go over some of the idiosyncrasies about that Docker image for you during this presentation. So again, as discussed in the opening ceremony, we do have a few different kind of convenient GitHub repos set up for you to use. In this particular presentation, we're going to be talking about the simple boilerplate. This is not the one that has been enabled with Demux. Demux being a technology that we have released relatively recently. If you're familiar with Demux, feel free to use that boilerplate. If you're not familiar with Demux, or you just want to take the simple route, the simple boilerplate will get you where you want to go. It comes equipped to go ahead and take advantage of our Docker environment and get you set up most of the way with a blockchain, with some accounts on that blockchain, and with an example application that you can poke at and get used to it. We're going to take you during this presentation a little deeper into it so you can see what will need to happen on the back end as you start to develop your dApp and you want to do things like create additional accounts, maybe import some private keys to a wallet. So when you download that repo, the easiest way to get it started is just to go through and run the quick start. That will do basically a three-step process. One is a first step initialization that will get everything set up. The second step is to launch the Docker container, and the third step is to launch our React-based demo application. After you've gotten the initial setup done, if for any chance you stop the Docker container and you want to restart it, there will simply be a single command to run that, and if you ever stop the Redux application, you want to start that, there's also a simple command to do that as well. Those are all basically the shell files that you'll find at the root of that repository. As we've mentioned several times, the command line interface for this application is Kleos. Kleos will be instrumental in creating new accounts and importing private keys for a lot of your back-end operations, particularly and most importantly, uploading a contract when you're ready to do so will be done through Kleos. And we're going to walk you through that from start to finish a couple of times during this presentation. And I'll actually be typing out. By the way, the rule applies that whenever you're live in front of an audience trying to type, that's when you forget how to type. So please bear with me as I very slowly hunt and peck, but we'll get through it. Let's see. By the way, if this walkthrough that I'm going through right now looks unfamiliar to you, we have posted it several times in the Slack channel. If you have not joined Slack, now is an excellent time to do that, and it's EOS London Hackathon? Hackathon London? EOS Hackathon London.slack.com. The mentors can also help you get logged in. There's plenty of information there, so you don't have to try to follow along right now. You can download this later, and all the links are there. The other thing that I forgot to mention at the very top, and I'll mention it again, we mentioned it in the opening ceremony. When you want to go to the documentation, the portal, make sure that the first time you go, you put !hackathon. That will get you all set up to make sure that you are following the version of the documentation that's going to help you the most. Again, not everything changed from 1.3, but just enough change to where it's going to be a distraction for the hack. You might as well use 1.2.5. It will just make your life easier. Okay, so let's kind of jump into some basic operations with Kleos. One of the things that you're going to want to do at the very first, whoops. Get that bigger so everyone can see. Once you download the Git repository, you'll want to be in the root of that repository for most of what we're kind of going through here. You'll see, as I mentioned, we have a couple of shell files. The quick start is the one that you'll run the first time. That will run all three of the other parts of it. Otherwise, the next time you do it, you might just want to run start EOSIO Docker if you've shut down your Docker container and want to restart it. There's also start front end to start the React application. So those can be used separately. If you run them separately, you'll probably want to do so in separate terminals so that you can see the logging for them. I'm going to go ahead and do the quick start now so that I have a blockchain up and running. And you can kind of see, I've already pulled down the image, so there isn't much to do there. It will run an npm install to go ahead and get some of the dependencies for the React app. And then you should see it go ahead and call a couple of starting things, and it will also open a web browser, which takes you to our React app. I'm not going to go through NoteChain right now. You can play around with it as you go through this tutorial yourself. It is a very simple, basic blockchain application meant to kind of give you just a general idea of how to use a blockchain application. Particularly, you can dig into the front end side of it and see how it interfaces with the back end, which will be very important for your applications. But for now, we're going to head and get back to the terminal. Come on, come on. How do I get out of here? There we go. Thank you. All right. So we've compiled successfully. This is actually running the React application, so I'm going to kill it right now because the rest of this will not depend on that React application. I do have a Docker container running at this point. It will stay running until you close it. So you notice we've also named the Docker container EOSIO_notechain_container. If you are very interested in Docker, you can dive into the shell script and rename that container. Otherwise, you can just leave it as this, and we'll all have a bunch of notechain containers. In order to get some access to our basic tooling, you're going to want to alias some commands. This will just make it easier for you to type as if the Docker container was native for you. Particularly when you're looking through the review, we'll have different aliases for you. Aliases are mostly useful for bash-based environments like Mac or like any of your Linuxes and stuff like that. If you're running Ubuntu on the Windows Linux subsystem, that will also work for aliasing. If you have a specific terminal emulator that doesn't support aliasing, you'll have to translate this to whatever it is that runs aliases for you. So I'm going to alias my Kleos command directly into Docker. In order to do that, if you're not familiar with Docker, we're basically going to use docker exec, which will run a command inside of a Docker container that is already running. We'll have to give it the name of the Docker container that is running, which remember is notechain, EOSIO_notechain_container. And then we're also going to have to give it the path to the command inside of that we're going to run. In this case, all of the commands that we're going to run are inside of /opt/eosio/bin. That's where we're going to find everything that we run in this. And then, for instance, right now we are aliasing Kleos. The other point that you'll want to note is that Kleos needs HTTP. Oh, are we off the? Oh, okay. Got a typo. Remember, as soon as you're in front of people, you forget how to type. So, are we good now? Container. Yeah, we went to a different line. I guess that's probably big enough to where I could have shrunk it a little bit, and you could still read it. Anyways, The last thing that Kleos will need is an RPC server to talk with. We've got one configured inside of that note chain container that you can talk to directly over the HTTP interface. It is shared after you start the container with the scripts on your localhost port 8888. So that's going to look like this. It's -u HTTP localhost 8888. So that's an alias. Since we've got a blockchain running, we can now directly use Kleos on our command line. For instance, getinfo is a handy command to see what your current blockchain is doing. That should give you a response that looks roughly like this. It will tell you what block number you're on. It will tell you what the irreversible block number is on. It will also give you some basic information about the resources on that chain and the time according to that chain. If those are relevant to your application, this is where you would get them. So if you just want to make sure that, for instance, your chain is going forward in time, we can see by polling getinfo that we have, while I've been talking, gotten 41 more blocks onto the chain with not much in there. One of the things that you will use Kleos for on the back end is creating new accounts. And in order to do that, you're going to have a wallet created that has some private keys stored into it. So Kleos comes built in with the ability to do a lot of those things. The first thing you will have to do, though, is just create the basic wallet. So that is Kleos wallet create. Oh, sorry, and I've already missed the first rule. In order to not leak too much private information to your console, you now have to opt in. This is a change if you've been with us from previous hackathons. Usually it would just export out to the console a password that you would need to keep so that you can unlock that wallet in the future. However, for security reasons, we now no longer default to putting that on the screen. We make you opt into it. So a change, if you've been with us from previous hackathons, is you will now attach the to console option at the end of this, which is --to console. Up and, oh, right, I already had a wallet created. I'm sorry. I should have deleted that before this. The default wallet name is default. So if you've already created that, then you'll get that. Otherwise, what you should have seen here is a password, which I conveniently stored in a file that no one will ever discover called .password. This is what that password would have looked like had we been doing this live. You'll just need to store that somewhere. If you lose that password, mentors can help you delete and recreate the wallet. If you lose the password and also the private keys, you might have to start your chain from scratch and recreate some of those accounts because now you're fighting cryptography and we might not be able to recover those for you. You can list the number of wallets you have by doing Kleos wallet list. And for instance, we see a couple of other ones that were injected by the by the running Docker container. You can also unlock a wallet. So once a wallet goes idle, you'll need to unlock it to get access to those keys. That's Kleos wallet unlock. You'll have to pass in a password to do that. You can do that at the command line, which --password. I usually store my password in a file when I'm not worried about security, so that I can just pass it back in like this. And that will unlock my default wallet, and now we should see that when we do Kleos wallet list, we see the default wallet. Ta-da! If it has an asterisk by it in the name, that means it's unlocked. That means you have access to the keys that are stored inside of that wallet. Our boilerplate will already set up wallets for you that have the private keys associated with the various note chain examples in there. Those are the ones that are in EOSIO main and note chain wallet. For your own personal use, you can put keys in that wallet. If you ever want to use Kleos commands directed to a specific wallet, for instance, if you wanted to get add a key to one of these wallets or list the keys in these wallets, you have to pass in -n and then the name of the wallet you're going for. Or at least I thought that's what you had to do. Oh, sorry, list keys is for all available keys in your wallets. Otherwise, if you were adding a key, you'd need to tell it which wallet it goes to, in which case -n is useful there. Creating keys is also very easy. You can just do Kleos create key. We try to make it as user-friendly as possible. And again, for this hackathon, new to this one, to-console will be your friend. That will print out a public and private key. Those aren't automatically added to any wallets. They're just created and then printed to the screen. So if you don't do anything with them now, they'll just disappear. However, if you want to add them to a specific wallet, you will need to copy out the private key and then call Kleos wallet, what is it? Import, sorry, import, dash dash private key, and then give it the private key part of that. And what we should see is that we've imported the private key. It will tell you the public key that corresponds to it, and that's now going to go into our default wallet. Just to prove that it works, if we wanted to create a second key, take that private key and put it in a different wallet in case that matters for wallet management. Here's where we could do -n and give it note chain wall or something like that. Private key. Import that one. Now that one's in a different wallet. So as wallets become unlocked and locked, we would have access to different sets of keys. Once you unlock a wallet, you have access to all of the unlocked keys. So there's no authentication past that. Let's see. We've already gone through list keys. Okay. So once we've created a couple of keys, for instance, as we've just done, the next level of authorization structure that you'll want to create in order to interact with the application is an on-chain account. Accounts on EOSIO have human readable names, and they are kind of a reference to a set of permissions and a set of keys. Just very quickly, to keep us moving along, Kleos create account is the command you're going to use to create a new account on the chain. Each account has to have an account that created it. In this case, since we've already got our chain set up through the boilerplate, we can use the root account on the chain, which is EOSIO. That's the only account at this point that really has permissions to create new accounts. And we can name this whatever we want, as long as it is, basically keep it to 12 characters. That's the good rule of thumb, 12 characters, all alphabetical characters and 0 through 9, including a dot. As long as it's 12 characters, it should go. Technically, you can go up to 13 characters, but that last character is a little weird. 12 characters is safe. Anything less than 12 characters is also safe. We don't have any restrictions on the note chain as far as the names on accounts go, which might be different than certain currently operating EOSIO-based networks that you might be used to. This is a raw chain, so it works that way. You'll also need to give it two keys, two public keys. Those will act as the owner key and the active key. For the most part, you'll only really use the active key for everything you're going to do, unless you get into the specifics of trying to do very complex permission management. That's outside the scope of this walkthrough, so grab a mentor while you're out there on the field if you really want to get farther into the permission scheme. For now, suffice it to say that you just have to give it two public keys back to back. So we'll take the ones that we just created, and those will be our owner and active keys. And you will see this kind of output that will tell you that basically we issued an action to the chain. The action's name is EOSIO and new account, so that's the contract and the action name that it got issued to. And you can also see the payload that went there. We'll see that the creator is EOSIO, the name is test account, and then we had a number of permissions that got sent up as a result of the public keys you uploaded. We can also do Kleos get account on that test account to see some information about it now that it's been created. Particularly if you're confused about what the public keys you use for owner and active, get account is a good way to get some basic information. It'll also, more importantly, tell you all of your resource quotas. For this chain, everything is going to be unlimited. So unless you run into an issue and you grab a mentor, you shouldn't see anything here other than unlimited. If you have deployed your own system level governance contract, that might change things. But again, outside of the scope of this hackathon, you probably don't need to worry about stuff like that. So if you don't see unlimited here, grab a mentor. We can help straighten you out. If you do see unlimited here, there should be nothing in your way from deploying as many contracts as you want, creating as many accounts as you want, etc. Another thing to note, actually, we'll get into that later. All right, so that's kind of our basic introduction into Kleos. The next thing we're going to introduce you to is EOSIO CPP, which is our compiler that will take C++ code and turn it into WebAssembly for you that is compatible with our chain. That is also stored within the Docker container. So the easiest way to go about your business is to go ahead and alias that. So again, if you're not used to aliasing, we're going to alias EOSIO CPP. We're going to make that into a different Docker exec from Kleos. Docker exec. Going to hammer it home. The container's name is EOSIO note chain container. And if you type it right, it actually works. And Do I have to go into the actual opt EOSIO bin, or should it be in the path? Okay. This one apparently is in path inside the container, so we can just do EOSIO CPP. And now we should be able to, get some help text out of that. These are the basic options. There are, for the most part, 3 different ways that you can use EOSIO CPP. One of them is not going to be all that useful to you. It will just create a skeleton project, but since we've already given you kind of a more fleshed out skeleton project, I would shy away from that. The other 2 modes of operation, number 1, are to take a contract code, turn it into WebAssembly, very important for uploading. The second one, which is also very important, is to take contract code and from that derive an ABI file. Serge has mentioned the ABI file during the opening ceremonies. That is the glue between your contract and most of the front-end tools that we have readily available for you. Inside of the code files that we go to, we'll kind of point out where the annotations inside of the code file go to point out to the compiler how to generate that ABI file. The ABI file can also be written entirely by hand. In some cases where you have particularly complex data, you might need to author one by hand. We've covered most of the cases with annotations so that they can be generated for you. Again, if you come up to a point where you're not understanding why your ABI is not working the way you expect, grab a mentor. We can help you with that. We're not going to go deep into the ABI during this presentation. So what does an actual contract look like? Here's a very basic contract that I've got set up for us already. Just a very basic example hello world contract. Looks about like this. This is C++ code. For the most part, we recommend you following a pattern similar to this, but any kind of pattern that you're used to working with contracts will also work. Particularly in here, there's a couple of things to take note of. One is the annotations that help us generate an ABI. You see at the very bottom of this file, we've got the EOS ABI macro, which will kind of show where the endpoints are for accessing this contract. So when someone is going to issue an action to this contract, they're going to be looking for the high action. The second thing is to note this comment right here, the @ABI action. That will label to the compiler that this particular method is an action method. And the compiler technology itself will take all the parameters, shove them into some types for you, and generate an ABI that can be used with an outside set of tools like our front-end tools. This is all very simple, so we're going to go ahead and back out here and show you how to compile it. One thing to note about this, you'll notice that I put this in a very specific place. Inside of the root of the repository, there is an EOSIO_Docker directory. That's the directory that gets mapped into the Docker container and is accessible directly in the Docker container. Specifically, we put all of our contracts under the contract subdirectory. That's also available inside the Docker image. This is important because when we actually type the compiler command, since it's aliased into the Docker container, we will need to give it paths that it understands inside the Docker container, not outside the Docker container. So even though this is in some file system on my local hard drive, when we actually type in the command to compile it, we're going to type in EOSIO CPP. And for compiling, we use -o switch and give it the place that we're going to output it. And you'll notice that this is also inside the Docker container. So /opt/EOSIO/bin/contracts. That's the same contracts directory that I've actually got in EOSIO_Docker contracts. It's just mapped through Docker. That's the way it appears inside of Docker as opposed to outside of Docker. So in here, I can go ahead and say example /example.wasm. .wasm is the file extension that we use for WebAssembly. It's just conventional. And then we have to pass in the files that we want to compile. At this point, we only have one file, so I'm only going to list one file here. But if you had multiple C++ files that you wanted to compile into a single contract, you would just list them one after another here in kind of the order that you need. Another thing to note while I'm typing this out is that the EOSIO CPP command will already include all the paths that you need to get to this kind of standard library of EOSIO, which is EOSIO lib. It will also give you access to standard C library, standard C++ library, and even Boost, I believe. So that's worth noting that you won't have to worry about trying to put in a whole bunch of /i or -i flags to get this to compile. Example. Yeah. It's always good to pair program, especially in situations like this. Do we think it's going to work? All right, it worked. That's good. All right, so as I mentioned, those are all the inside Docker paths, but these all got written to files that map outside of Docker. So if we look into our EOSIO Docker directory inside the root of our repository, go to the contracts directory there, inside of example, we will find example WASM. So it's there. We can upload that to the chain. Before we upload that to the chain, though, we'll also want to generate an ABI from it. Otherwise, nothing will know how to talk to it. That also goes through EOSIO CPP, as we mentioned. It's just the -G flag instead of the -O flag. So same basic path. We're going to give it this long, drawn-out path. And we're going to give it an extension of ABI this time instead of WASM. We still pass in the same set of CPP files or the same CPP files. It's basically a compiler. It's going to read type information from that and generate the ABI. You will get some warnings if you don't have Ricardian contracts. You can ignore those for now. We're not requiring you to put in proper Ricardian contracts for this. Although, if you're interested in the topics of Ricardian contracts and how that can affect your DApp, find a mentor. Mentors are very helpful for things like that when you want to do a deep dive on topics. All right, so continuing on. What that ABI file looks like, kind of bring this up, is JSON that basically describes some of the types and some of the actions that you see. So on there you can see that we've defined a struct that's a basic data type. It's called hi. It has just a single field, which is a name field, and then down at the underneath that, the set of actions that your contract can be accessed with, as well as the type that it needs to access. That's all the information we need for Kleos to be able to send an action to this contract. So that's all we need to do in order to actually build this contract, but we still haven't gotten it on chain yet. So we're going to go ahead and use Kleos, back to our kind of multi-tool Kleos, to upload that contract. So we'll do a set contract, which is the command for this. You'll have to give it the account that it's going to upload to. All contracts are hosted on an EOSIO-based account. So if you remember, we made test account before. We've already got the keys for that, hopefully in a still unlocked wallet. We've been a little slow, so maybe not. Then you tell it where to find the contract. Again, this is inside of the Docker container because we've aliased all that in. So opt EOSIO /bin /contracts /example. You can just give it the base directory. If you give it the base directory, it will look for a .wasm and a .abi file within that directory and upload them for you, so you don't have to worry about that. You will have to give it a permission. At this point, all of our permissions are the same because we haven't messed any with permissions, so you can just give it test account @active, and that will upload it. Oh, no, my wallets have gone unlocked. Oh, did I? Oh, no, yeah, it was just a typo. No one called me on it. What is it? Test. There we go. Okay. So what we see here is there's actually two actions that got submitted to the blockchain. You can do those actions independently. So if you ever upload, if you ever change just your ABI or just your code with no ABI, you can go ahead and call one of those actions. So we see a set code and a set ABI. That means that our contract's been uploaded once it's accepted. Now we can push a basic action to it. So Kleos push action will also be one of your go-tos. You need to give it the account that it's going to. So remember, we hosted it on test account. We're even going to spell it right this time. We need to give it an action name. If you remember from the ABI, our action name was hi. And then after that, we just need to give it a JSON payload, JSON encoded payload, which in our case was just a name. So we'll also give it a name for, yeah, there we go. We will also need to give it a permission. The last thing we do for most of these commands that actually hit the chain is authorize it with a permission. We're going to do test account @active again. Hit that, and we're going to go ahead and see that one of the things that it did was print hello test account, which is exactly the only thing that our example contract did. So we've successfully kind of walked you through a basic contract, very basic contract, generating the ABI of it, getting that to interface with our multi-tool Kleos, and then even dispatching an action to it. Those are kind of basically everything you need to know. I'm going to turn it over to let Khaled start talking about more topics. I'm still going to be typing, so feel free to make fun of me, but he's going to take over the actual speaking part of it.
Okay, so the token contract is one of our native contracts. It manages basically, as the name implies, it manages tokens, does transfer issues, and so on. The token contract is already created, and it's deployed on the EOSIO.token account. So probably we need to create that account first.
I'm creating for you right now.
Okay.
Now I feel like everyone's watching me create the account. Why don't you tell them more about the token account and what that's going to give them once we upload it?
All right. So the first thing you would want to do is create a given token, and to create the token is first what you need to specify. First, the action is create. What you need to specify is the issuer, is the account that is allowed to issue this token, the maximum supply. When it's created, when the token is created, it's the supply is 0. But the maximum supply is the maximum that the supply of this token can reach, and it encodes not only the supply, not only the amount, the supply, but also encodes the token symbol. Let's say EOS or anything, DLR. And it also encodes the precision. For example, EOS has precision of 4. You can have 0.0001 EOS tokens.
Was I supposed to get the token contract from somewhere, or was it already there?
It should be here.
No, it's not there.
There.
And Serge just left. Okay. We can get you access to the token contract at some point.
If we can just go through the through the nodes.
Yeah, that's fine. So bringing back up the notes at this point. Come on. That's not what I wanted to hit. That's going to be bad. All right. So this is what you saw me typing in there. It's just creating enough public-private keys to create the EOSIO token account. Once you have the token contract and you upload it, as Khaled was saying, the first thing you will need to do is create a token. So the token account doesn't actually have a single token. It has as many tokens as you wish. And so in order to define what the token is, you'll have to go ahead and issue first a create. This is what that action looks like. It's the create action. I can let you.
Yes. So the issuer is the account that is allowed to issue tokens. Maximum supply tells you up to how much you can, how many tokens you can issue. It also encodes precision. You give it some like decimal points, and these decimal points are important because that will give that will tell the precision of the token amount and the symbol. And in this case, hack.
Also, remember, you always have to give it an authorization. Otherwise, you'll get a very scary error message saying you're not authorized.
Yes. So the two main actions in this contract are transfer and issue. In this case, we're showing an example of issue. And the amount that's going to be doing the issuing is the amount that we set at the beginning when we create the token, is the issuer. And it's EOSIO. That's why it needs the permission of EOSIO at the end. And we're issuing 100 tokens to test account. And a memo is a message, a memo. Notice that when we issue, it adds to the supply. So if you keep issuing, you can at some point hit the maximum supply. The other action that is a transfer The other action that is a transfer, it requires two accounts, the transfer from, the transfer to. It requires the amount we're transferring here, that's 25, and a memo. In this case, we're just giving it a dummy memo. What it requires is a permission of the from account. So if I'm transferring to someone, it requires my authorization. Transfer, as opposed to issue, doesn't increase the supply amount of the token. Basically, it subtracts from one account, adds to another account, so it doesn't change the total supply of the token. Yes?
Is it possible to manage several tokens in the same token smart contract?
I'm sorry, can you say it one more time?
Yes.
So the question is it possible to manage and issue multiple tokens in the same contract?
Yes. So here we create, in the action creates a token. We created a hack token. We can create another token. Let's call it DLR with any precision you want, up to a maximum precision. I forgot the exact one, 10 or something, or 18. And then you can manage that that token. So these tokens will have their own tables for balances and so on. So you'll so in each transfer, in each issue, after you create, in each transfer, in each issue, you'll have to give it a parameter. That parameter is an asset of type asset, and asset has two fields. It has a quantity or amount, that's an integer, and it has the token. What token you are transferring or issuing.
So the answer is yes, and you always basically have to disambiguate which one you're transferring by tacking that symbol onto the end of your transfers and your issues and things like that. But otherwise, you will just see multiple tokens in the same account. You should be able to get away with only having one token contract on the chain, unless you really need to change the mechanics of the token.
Yes.
Can you write any name for the token?
No, there are limitations on the token. Do you remember?
On the symbol of the token?
Yeah, the symbol.
I think it can be up to 4 characters. And I think that it's basically just characters.
It's more than...
Capital characters, A through Z.
More than 4, but
Yeah.
Maybe 11 or so.
In the hackathon, we can use just Z name as like...
Sure.
Yeah, you can
Sure,
just
yeah.
use any name you choose.
Whatever name you want to choose. We're just kind of showing you the basic mechanics. You can call it hack. You can, call it sys or anything like that.
Yeah.
Thank you.
Mm-hmm. Okay. Are there any other questions about basic token contract usage and management before we move on to kind of a deeper topic? Okay, let's just move on. We got one more topic to cover.
There were a few questions though.
Well, I don't see any hands. No. Okay.
Go ahead.
Does the order of the parameters matter when you put in the JSON scheme?
So this is a good question. The question is, does the order of the parameters matter when you put it into a JSON scheme? Yes. For the most part, there's 2 ways in which we can take the ABI file that I showed you and map it to JSON. So real quick, I'm going to bring back up the ABI for that contract so we can, at least I thought I was going to do it real quick. But okay. Basically, when we issued an action, the way our data structures are encoded into JSON can actually go multiple ways. You can either list it as an array in JSON in the order in which it appears in your C++ file. So if you have parameter 1, 2, 3, 4, 5, you would need to list them in the array that way. You'll notice that the ABI is also able to pull out names of those parameters. If you structure your input to Kleos as a JSON object, then obviously you can have name-value pairs, and you can order them in whatever way you want to, as long as the name maps to the parameter. So order does matter, but it really only matters specifically when you are going to do JSON input with an array, which is what we did for our action. It would have worked both ways.
There was a question over here.
Okay.
Hello, I asked it on the Slack, but I suppose it would be just faster to ask it here. So I see 3 example contracts in EOSIO Docker contracts, right?
Mm-hmm.
When I checked out the master of the repository, I see only one node chain.
Yes. So when you check out the repository, there will only be one example. Inside of this walkthrough that we've been kind of using as an aid, there are the complete code listings for the other two examples. I had just gone ahead and prior to this presentation copied and pasted those into my directory, so that's why you saw multiple contracts there. So for instance, our hello world example, if you follow this walkthrough exactly, would end up in the example directory, and the one we're about to go through would end up in the other directory.
Thank you very much.
You're welcome. Anything else? Are we clear? Oh. No?
So when you do a transfer, is it the same, the number of decimal places after the point, is it the same as doing 12.1, or would I have to do 12.1000 to get like 4 decimal places?
No, you need to give the right number of decimal places.
So the question was whether or not you need to include trailing zeros in your transfers and everything operating with the token. The answer is yes. If it starts off with 4 digits of precision, use 4 digits of precision for all of your JSON.
Actually, what defines the token is not just the symbol itself, it's a symbol plus precision.
Hi, I have a question to the prior topic. What is the relation between wallets and accounts? What exactly, is something on-chain, or is it just you have entropy somewhere and just derive HD keys all the time? How everything is connected?
Sure. We could spend several days talking about that, so I'm going to give you a very quick rundown. On-chain, we have the account name, and then we have a set of permissions. Each permission has a data structure underneath of it that can actually be multiple things. One of those things is a public key. So when you look on-chain, the data that you will see committed to is a combination of account name, permission name, and public key for the ones that we've set up right now. If you want to get into complex topics like multisig, that would end up being an account, a permission, and then multiple public keys with some sort of satisfaction threshold or whatever. You can also do things where you delegate authorities over to other accounts by listing accounts in those permissions. We can talk about delays and stuff like that. Those are all very advanced topics. If you want to use something like a multi-sig authority attached to one of your permissions, grab one of the mentors. We should be able to guide you through it. We can't go completely into a deep dive of the permission and accounting structure during this presentation. We just don't have enough time.
Thank you.
You're welcome.
When generating the WASM and the API files, do you have to specify the full path of the CPP files and where you want the respective files to be created?
So the question is, when we were using the EOSIO CPP tool, do you have to use the absolute path to the file, or can you use relative paths? When we've mapped it into the Docker container, as we have done now, you're going to have to use the absolute paths. That's just kind of an artifact of the way that we've mapped into the Docker container. If you are working in an environment where you've got that directly installed on your host, they don't have to be absolute paths. So that just takes a lot longer to set up. And so as a means of convenience for the hackathon, to save you some time, we gave you the Docker container, and then this is just an artifact of that.
Possible to search on the account names by keywords, for example, if I'm looking for an account?
So the question is it possible to search for accounts based on keywords or anything else? The answer is no. You can basically get information about an account if you know the exact account name, but there's no softer way to look up accounts, at least not one built into Kleos or the chain.
Any other questions?
Okay, we have one more topic we'd like to introduce to you because it's very important before we let you go. That is how you're going to store data on the chain and get it to persist in between actions. So I'll let Khaled get back into talking, and I'll get ready to show things.
Okay, so we have a very simple contract, but it just it demos some of the ways we use the database tables. The contract we're calling is address book, and the idea is that users can add records to this address book, update the records, and delete the records. So we create the CPP file, and then we start with creating the class. It's going to represent the contract, and call it address book. And it inherits from EOSIO contract. Basically, EOSIO on contract only has one field called _self. And the account that deploys this contract will become _self. We're not showing it here, but this is for reference. In the private part of the private fields part of the class, we're going to define the schema. And basically, the schema is represented by structs. In this case, the struct is a record. We're calling it a record. And if you think of, let's say, a SQL database, a struct would represent a row in this database. And the fields of the struct will be the columns. Here in the record, we have owner, which is of type account name. A phone number of type UN32, a full name, which is a string, and an address, which is a string. We always have to define a primary key, which is going to be unique per table. In this case, the owner is a unique primary key. So we define this method of the struct called primary key. It doesn't have to be the field itself. It can be a function of the field. Here, for simplicity, it's just the owner itself. Secondary keys, we can have multiple secondary keys per table. In this case, I'm using by phone as a secondary key. So a phone as a secondary key, and the function that defines the secondary key, I'm just calling it by phone. The primary key itself, once you define the function primary _ key, then you're done. The secondary key is a little more elaborate, and you have to include it in the definition of the table. And the table is of type EOSIO multi-index, which is similar to the Boost multi-index. Let me go through this long definition here. N parentheses records. This records will be the name of the table in the database when we try to look up at the table. Record is the type of the row in the table, so which is the struct here. And then we define by indexed by. We define the set of secondary keys. Here we're only using one secondary key, which is a phone number. So this, the type of the secondary key, the type that we extract the secondary key from, the type of the secondary key, which is a UN64 type. We have a few types that can be allowed to be used as secondary keys. One is UN64, UN128, double, long double, and 512 integer. So we do that a type def, this large template to a record table, and then the class will contain an instant of that type, which is _records. I want to mention this again. Primary key is unique, as in forced to be unique. Secondary key is not necessarily unique. It depends. Then you set the logic depending on your application. When we in the class constructor, since the constructor inherits, or since the class address book inherits from EOSIO contracts, we define and we construct contracts, a base class in the constructor, and we construct the tables. In this case, we have one table _record. To construct the table, we need two fields. We need code and scope. In this case, in the simpler case, which is this case, code and scope are the same. And the code and scope will be the account that is deploying the contract. So whichever account deploys the contract will be this S here, account name S. So far, we have this. We have the class that is by now complete without the minus the actions. We have the constructor. We have the schema defined as a struct, and we have the tables. In this case, we have one table, which is underscore records. And now I'm gonna define an action that adds a record to this table. What it takes is the account name, the owner of type account name, the phone number as an integer, full name, etc., and address. The first thing you would want to do in an action is require auth, meaning that some account has to authorize this action, and then in this case, it's the owner of the record who is creating this record should authorize this action. And we also have some sanity checks. For example, I don't want the full name, the size of the full name to be more than 20 characters. I don't want the address to be more than 50 characters. And then the check above is I want the owner, the primary key, to be unique. Now, the uniqueness of the primary key is enforced at the library level, so we don't have to do this. But I included it here so that we can get a more meaningful error message than the generic error message that the library would give you. Now, so in addition to the uniqueness of the primary key, in this application, I want to enforce the uniqueness of the secondary key, which is phone. This is not guaranteed by the library, so I need to enforce it myself. And this here is an example of how to use a multi-index container and how to use a secondary key. So the index here is one of the, in this case, we defined only one index and one the secondary key. So we get it by the name. So by phone is the name of the name of the index, and it belongs to a table, the table records. And then I look for find is search. I search for that phone number, and I want to make sure it's unique. It doesn't exist. So if it exists already, the adding this record fails, and it tells you that the phone number is already taken. If it doesn't, we move on. And then to add a record to this to the table, we have the function in place. And in place takes as an input lambda, C++ lambda function. And here we define the fields of the structure. So basically the fields in the record, which are owner, phone, full name, and address. And we set them to the fields that we input to this action. Yes. If you notice here, we have this owner field also in this in place. And this is important. Owner will be the account that is going to be charged for the RAM, because when you're adding a record, you're consuming RAM, and someone has to be charged for this RAM. And in this case, it is the person who is adding the record. This is more usually the case, but sometimes you wanna depends on your business logic who you charge the RAM for, the RAM to, and in this case, we're setting it to the owner, the person who is creating the record. Every time you create an action, you want to add it to EOSIO ABI that Bart described earlier. So now with this, with the create action, the class starts to look more involved, and it looks like this. Now we want to add two actions. Want to add a remove action and an update action. Remove is simple.
I'm starting to create accounts for you. Sorry.
Oh, yes.
You can keep describing.
Yeah. Well, it's.
Oh. You want me to show them remove? Got it.
So remove is simple. Remove basically just removes the remove the record from the table. Again, the owner of the record should be the only one who is authorized to remove that record, which is the case that makes sense. And first, we look for the record to make sure it's there. You cannot remove something that's not there. And to see that it's not there, the iterator, that the output of find should be different from end. That's how you check that the record exists. And then you erase the iterator. This is a simple action. Update is a little bit more involved. Again, only the owner of the record can update the record. We look for the record, make sure it's there. In this case, for simplicity, I'm only updating the address in the record. So again, I want to check that the new address is not too long. And then to update, we have the multi-index method modify. And to modify, you need to pass the iterator that you want to modify. Again, the RAM, counts responsible for the RAM, and a lambda function. And the lambda function describes how you want to modify this record. And in this case, I'm just setting the address to the new address. So I think this is the more or less the description of this contract. And we now can have a demo.
Yep. I might have actually finally expired my wallets. Yep, they're closed. All right, so I'm going to create a quick account for the address book contract itself. And I'm going to create a user account for it as well. We're going to affectionately call that Khaled. Okay. As before, we're going to Kleos set contract for the address book account. Okay, we got 10 minutes, and we'd like to give you more time for questions, so type faster. So we're going to upload the contract. That puts both the ABI and the code up there. And then we're going to go walk through the actual actions on the contract. So the first thing we had to do was create an entry in that contract. So if you remember from before, Kleos push action is kind of our generic way of getting an action onto the chain. We do need to give it the account that it's going to. In this case, we deploy the contract on the address book account. That could have been any account, but we decided to call it address book. We're going to issue the action name. Remember, the action name was create. And then we're going to give it a JSON payload. Again, this time we're going to use just the array version, so we had to put them in the same order that the action expects. But if we had used JSON object notation, we could have shuffled it around, which might be useful for your user case. Our account name was Khaled. Our fake phone number is 332233. Go ahead and try to dial it. You won't get Khaled. Khaled's name is Khaled A. That's all we're going to worry about right now. And his location is, of course, Springfield, where all Khaleds live. There's an entire colony of them there. So now on to the most important part of this particular action. If you remember from our contract, we did require auth at the beginning of this action. We required auth of the person who is going to be listed in the address book, not the contract address book. So now when we're actually typing this action out, we need to authorize it with someone. We're not going to authorize it with address book because that account's irrelevant at this point. We're going to instead authorize it with Khaled, and that will give us the proper authorizations to actually do this action. So we'll see here that we got the output we expected. We delivered an address book -- create action to the address book account with this kind of payload. And that's going to have created an entry that persisted in the database. So just real quick, we're going to show you how to get to that. Kleos get table. You need to give it the contract and scope that you deployed the table on. So our contract is, address book. And if you remember, when Khaled was going through the constructor, we passed the same name into both the contract name and the scope name. So our scope name is also address book. If you get into complex examples, your scope might have changed. And then the table name, if you remember, was also record. So just by calling Kleos get table, we should be able to see that we've got the entry that we expect to see. Khaled, the name, the address. You also see an indicator here that tells you whether or not there are more records. This would list the entire table, so if we had thousands of accounts, we could put them all in there, and it would have only given you the first, I think, 10. If you look through the help text of Kleos, there's a way to adjust the paging as you go through the table. It's the same with the RPC interface. We could show you a quick update on that.
And then you've got a question over here.
Yeah, actually, the walkthrough will take you through the rest of the actions. They all operate the same way, but since we have a short amount of time, I want to go ahead and open it back up for questions just to make sure we get as many of them as possible. So, show of hands, who's got a question? Okay, lots of questions. He already has a microphone, so we'll start there.
Yeah, when passing parameters in array, not with a JSON scheme, does it matter if I put quotation marks on strings or not?
The action data will need to be properly formed JSON. So JSON has quotation marks around both the strings and the field names if you're in an object form. Mm-hmm.
For example, typing Khaled, if I would type Khaled without quotation marks?
No, I don't think it would work without the quotation marks.
No.
Can we try it?
Well, we've already got an action there. I can try it right now while we field the next question.
Okay. Try it with update.
Yeah. Now we're under a time limit for. So you just want to see if it works like this? I'm 99% sure the answer is no. We're going to put it up here too.
We'll first make a -p.
Okay, I was wrong. It worked. There you go. So apparently sometimes invalid JSON works.
How scalable is this type of database? It will work with like 1 million rows?
So basically the scalability of the database is completely defined with how much access to data size that your node has. By default, I'm not actually sure what our Docker container will give the database for RAM, but if you ask a mentor, we can get you set up to where you're running a node that can have access up to gigabytes, terabytes of RAM even, if you really need that much RAM. It's all hosted on a single node right now, so your laptop or whatever device you present with will need to have access to that much RAM in order to do it. But it should be, from a size perspective, scalable up to anything that your laptop can throw at it. All right.
So presuming that one day this goes onto a public blockchain, is the data in some way protected, or is it just plain text?
So there's no encryption on the database by default. Anyone who has access to the blockchain and has access to a Kleos connected to the blockchain would be able to read the exact same records. There's also no access control on those records. We didn't have to type any passwords into Kleos. So you would consider anything on a public chain to be public information, for sure.
Okay. Do you have any recommendations of encryption techniques to use?
I'm not going to recommend anything since we are at a hackathon where the theme is about such topics as data security and privacy. Please, hack that out.
All right, any other questions?
We had one down here, I believe.
Go for it. You're close enough.
Yeah, just go ahead and ask.
I think you mostly answered the question as to how the database is protected. And also my additional question would be, how would you transfer the access from owner to someone else? I guess that is not possible because it's already open.
Right. So the question was, how would you transfer database access rows or access to database rows to someone else? As we answered in the previous question, basically all the rows are open to the public, so anyone can read them. Just to circle back to it, all of the write permissions on the database are owned by whatever contract created the database row. So all of your rows are underneath that contract's namespace. The business logic of the contract will define basically what accounts are authorized to update, remove, delete rows, and it will also, as Khaled said, define who is paying for the rows. Those don't necessarily have to be the same entities. So you can have a contract that defines the ability to write rows to a certain set of users and the ability to pay for rows to a certain set of users. If they line up, they line up. If they don't, they don't. Any other questions before we let you go?
What happens if you change a schema on one of those structs with the data in the table row?
Excellent question. So the question is, what happens if you change a schema on one of the data in the row? Since you are running a private blockchain on your own laptop, you could wipe the entire blockchain and start from scratch. The real answer, though, is that for the most part, there's no automatic data migration. There's no automatic anything. So if you change the schema for a row after you've written to a row and then you fetch one of the rows that was written beforehand, it's going to try to interpret the literal binary data in the new schema and probably give you something that you're not expecting. So a quick hack, because we're at a hackathon, is if you want to reset your database without resetting your chain, change the name of your table. Just add a 1 to it, add a 2 to it. If you get up to a couple of thousand, we'll have a problem, but you can kind of serialize it that way. Are we out of time?
Sorry, guys. Out of
All right.
time for the C++. Give it up for a C++ folks.